So I'm going to take a look at this video by Ranty, and it is titled Sinking Experiment Crushes the Globe Rhetoric for Observations. So this is Ranty's setup. He's taken a photograph of a paint can and a ruler through a sugar water solution, and in the middle of the fish tank he has a cone-shaped object. Now, I'm really not certain why Ranty didn't compare a sugar water solution to plain water, but this was his setup. So to the existing water on the left, he added a mixture of 1,450 milliliters of sugar with 1.5 liters of water. And then for the photograph on the right, he added an additional 2,000 milliliters of sugar with 1.5 liter of water. Of course, there is increasing density at the bottom of the fish tank, and at one point Ranty did shine a laser light through it. And when you compare it to a straight line, you can clearly see that the laser light is bending downward. And of course, we know that downward bending light is the cause of looming. Looming is also a very simple concept to understand. So here we have an observer looking at a sailboat off in the distance with no refraction. So the light travels in a straight line. Now I've added a light path that is refracted downward. So this light path enters the observer's eyes at a higher angle. So to the observer, the sailboat appears higher than it actually is. But Ranty's making the opposite claim, that the object is actually lower than it really is. So let's take a listen to Ranty.
These two images were taken in different density gradients. The first image on the left was taken after adding 1,450 ml of sugar and 1.5 litres of water to the water already in the fish tank. The second image on the right was taken after an additional 2,000 ml of sugar and 1.5 litres of water were added to the fish tank. You can see that the pot I placed in the tank lines up pretty well in both images, and the cumulative effects of the density gradients have not had enough length to make the object move its visual position. However, when you look at the tin of paint in the right-hand image in the background, you can see that it is sunk in relative position to the pot. This proves that on a flat plane with a density gradient, distant objects will fall out of their expected positions and appear lower in the image. This very simple demonstration has proved Miles Davis and co. wrong, and proven that sinking is indeed a very real reason as to why we see things the way we do, over our wonderfully flat plane. I've been Ranty Flat Earth, and I'll see you all in the next one.
So Ranty aligned the top of the cones in both photographs. And when a straight line is drawn across the top of the can on the left, it does appear that the can on the right has sunk. The top is definitely lower. But let's take a look at a few more things in these photographs. Now, when I draw a line across the top of the number 5 in both of these photographs, we really don't see any change at all. There also doesn't appear to be any change at the bottom of the label on the paint can. But what do we have here? That mark on the piece of paper is definitely higher on the right, so that is a definite case of looming. And is this the number 6 up here in the right photograph? I mean, that number is blurry in both of the photographs, but I certainly don't see it in this area. So here's another case of looming. The bottom of the paper is also higher on the right. This black line on the left over here is also higher on the right. And we see the same thing with this dark band to the right of the cone, because over here in the right photograph, it is certainly higher too. So you got to ask the question, I mean, there's clearly real evidence of looming here, and yet in the middle we have one example of sinking. So why is this? Now, I don't have the answer because I did not do the experiment. But one thing might be is that Ranty might have just arbitrarily used the top of these cones for the alignment. So let's try something a little bit different. So what I did is took a cutout of the photograph on the right and I moved it up slightly so that the top rim of the paint can are now in alignment. Now, of course, the cone on the right is also a little bit higher, so it has loomed up. And look at this. Now everything is loomed upward. And this is exactly what we would expect to see when we have a density gradient that is bending light downward. So all I can say is thank you, Ranty, for more globe evidence.